Okay, we're going to talk about functions. Most of this class is going to be about different types of functions. So we need to know some vocabulary as it relates to functions, because when we start graphing, we need to know things like the domain, so we know which values we should put in, which values are going to create a problem, especially when we get to rational functions. They, certain members of the domain are going to create asymptotes and things like that. So we need to know which values work, which values don't, and we need to know kind of a basic level of understanding of what a function is. So we're going to go over those things. The domain is all the possible inputs. So that's all the numbers that you can put into an equation for a function that will give you real numbers out. The domain is usually the x variable because that's our inputs. That's the numbers we're putting in independent because we get to choose what it is. The range consists of all the y values, all the numbers that are going to be coming out. So we'll put a number in, we'll do the function, and then it'll tell us what the answer is. Okay, that answer is our y value, our dependent variable. It's dependent upon the x that we put in. Okay, so y depends on x. So a function is kind of the thing that happens as we put x's in. So we pick an x, the function tells us what to do with that x to get our answer. Okay, so the relationship or a map takes you from your input over to your output. Here's a real basic example of what a function would look like. Okay, you're going to have a set of inputs. These are your x values. You have a set of outputs. These would be like our y values. And the function tells you how you get from set A. You use the function in order to get to set B. So in this class, we're going to be using the real numbers as both set A and B. Real numbers are your rational numbers, anything that you can express as a fraction, and your irrational numbers, so anything that can't be expressed as a fraction, such as pi or the square root of 2. Numbers where if you type in your calculator, you just get a decimal that goes on forever and it doesn't have any pattern to it. It's just a bunch of numbers, one after the other. Those are irrational numbers. Numbers that are not included in the real numbers are complex numbers. So not complex, which includes imaginary. Okay, so we're not looking at imaginary numbers. So we're not going to have any imaginary numbers in our range, and we're not going to have any in our domain. And if we have any numbers in our domain that takes us to an imaginary answer, then we exclude that number from our domain. So in this example, I'm going to use x plus 5 as my function. So what that does is it takes an input and it tells me how to get it over to my output. Okay, I'm going to add 5 to it to take it to the output. Okay, so 6 is going to take me to 11. The function takes me there. The function takes 8 over to 13. And it takes 4 over to 9. Okay, now if you notice, every input that I have, okay, every one of my x values goes to one of my outputs. But I do have some outputs here that don't have inputs associated with them, and that's fine. Okay, I'm going to get to the function rules, but that's one of them. All my inputs have to go to an output. I don't need to have all my outputs, accounted for. Okay, another rule is every input can only go to one output. So 6 is only going to 11. Okay, if 6 was going to 11 and 5, then I wouldn't have a function. Okay, so let's skip some of this stuff. Here's some other representations of functions. Okay, the same sets that I have up there. I can have a table. because I've got inputs associated with their outputs. Or I can have a graph. I have inputs, which would be the x value, associated with outputs, which is the y value. Okay, this point is a relationship. Okay, it tells me which x I have and which y. Okay, same with all these other points. This input gives me that output. Okay, so if I follow this up, it tells me that that's my output. Okay, and graphs are the ones that we're going to work with most. Here's your rules. They're on page 16, but they use a little bit different language in your book. So if you get a chance, you should look at that language, start learning kind of what it means and how to interpret the language they use in the book. I've simplified it here. So rule number 1, each input has to go to an output. Okay, like I said up above, everything in your set, everything in your domain has to take you to something in your range. If there's something that doesn't do this, then it's not in the domain. Not all the numbers of the range have to be matched. Okay, you can have leftover numbers, numbers that aren't going to show up. You can have more than one input that goes to the same output. So let's say my function is x squared. Okay, if I have inputs, so if x equals 2, okay, the function takes that over to 4. If x is negative 2, the function takes that over to 4. So I've got two different inputs going to the same output. That's okay. If x equals 3, and the function was taking that to more than one answer, okay, that's not okay. That would make it not a function. Okay, you can still graph these things. They're still, graphable. You can do a lot of different things with them, but they're not defined as a function of x. Let's see. Okay, we're going to skip that. Okay, there's a couple ways to test to see if something's a function. So I've got two things up here. If I look at the blue line, I need to make sure that every input only has one output. A quick way to do that on a graph is to see if you can make a vertical line anywhere on this graph that's going to touch it more than once. Okay, so the blue line, everywhere I put the vertical line, it's only touching once, so that is a function. I talk about the red line. If I put the vertical line there, this x value has two y values that are coming out. Okay, so it's taking it here and here. So that means it's not a function, because I have an input that's giving me two outputs. So red is not a function because of the vertical line test. Algebraically, put shade up here. Algebraically, we're looking, and we're just going to kind of ration things out and figure out if I could put an x value in, is it going to give us two outputs? Most of the time, if you have a plus or minus in there, that's going to be telling you that you're going to have two outputs. Okay, so here's an example. We've got a y squared. If I solve it for y, okay, I have to divide by the -1. And then I have to square root. Okay, and the rule is, anytime you square root in order to get rid of a squared, you always have to put plus or minus. Okay, and this comes from the fact that if I say, x squared equals 4, well, the things that I could put in for x are 2 and -2. But if I solve this, and I don't put that plus or minus, I'm going to think that x can only be 2. So that's why we always put the plus or minus in front of our square root whenever you're using it to get rid of a squared. If they say, y equals the square root of x, you don't add in the plus or minus there, because you're not doing it to get rid of a squared. It's already given to you. Okay? So you don't need the plus or minus there. So here, I've got a plus or minus here. So if I pick a number, if I put in a value like 10 for x, it's going to spit out plus or minus the square root of 1, which is 1, and negative 1. Okay, so again, I'm getting 2 outputs from a single input. And if that happens once, it could happen lots of times, or just once. Just once means it's not a function. Okay, there's function notation. Our book is always going to use this. It's pretty handy. And when we get into calculus, it's the standard, so it's good to get used to. Basically what it does is, it tells you what a function of x is. So here's f of x, here's what it's equal to. So it's saying, if you've got an x value, you need to subtract 3 from it, then square it, and then multiply by 2. So if you're taking the function of 2, 2 has replaced this x. So that means that this x is going to be replaced by 2. Okay? And then you're going to do exactly what the function told you to do with x. You're going to take it, subtract 3 from it. Okay, then you're going to square it. Then you're going to multiply by 2. That would mean that f of 2, when I put 2 in for x, my function value is 2. We're going to skip this. We're going to get to piecewise later. I do want to point this out. Okay, this is a different notation you can use for describing ranges of numbers. So this parenthesis, you don't include that in your range. The bracket is when you do include it. So what this is saying is, here's my function value when x goes from negative infinity up to and including 0. So this is the same as writing same as writing x is between negative infinity and less than or equal to 0. Okay, so this is less than or equal to. Okay, this one would be the same as writing x is between 0 and 2. Okay, this would be the same as writing x is greater than or equal to 2 and less than infinity. Okay, parenthesis means you don't include it, bracket you do. So we're going to use that when we start finding domains. Okay, in order to find domains, we need to find out which numbers cause us problems. Okay, which numbers make it undefined, which numbers make it imaginary for now. Eventually we'll get to where we're dealing with imaginary numbers, but for right now we're not going to. We just want to look at the real numbers. Okay, so we're going to look at a couple examples of where, which type of equations we need to use for finding domains. So here's my first example. Now, the problem I'm going to have here, since I'm square rooting, I can't square root a negative, because that's going to give me an imaginary number, and I don't want that. I want real numbers. So I need to find out when. I need the inside of that to be greater than or equal to 0. Well, there's going to be a lot of numbers where it's greater than 0. But there might be just a few where it equals 0, and those I can find, right? I can set it up to be equal to 0. That's pretty easy for me. So those are the key points I'm going to find. If I take 9 minus x squared, set it equal to 0, and then solve, okay, there's that plus or minus again. Okay, so these are the values where it equals 0. Okay, so when we're looking at functions, the reason that them equaling 0 is good, because this graph is crossing 0 here and here. That means it's either coming from up top, crossing it, and then crossing back up, or maybe it's coming from down below, crossing, and then crossing to go back below. We need to figure out which one of these is happening. Because if it's the blue one, that means that, you know, all these numbers over here are good because they're positive. Right? And I want positive numbers under my square root. All these numbers would be good. And these numbers in here would not be good. If it's the green line, that means that all these numbers are not good. These numbers are good, and these are not. So I need to figure out which situation I have going on here. In order to do that, I'm just going to pick numbers that are in these 3 different ranges. Okay? I'm going to pick a number from this area, pick a number from this area, and a number from that area. And see, you know, am I dealing with the blue situation or the green situation? I'm going to put in -4. Okay, so if I have 9 minus -4 squared, and this is what I'm really doing is I'm finding the function at -4. Okay. I'm going to have 9 minus 16, which is -7. Okay, so I get a negative answer. That means I have this green, I probably have this green situation. Okay, so I'm getting negative answers here. But I still need to check. I don't want to just assume that it's going to follow that path. It could be doing something really weird. Okay, because sometimes it have double zeros and it'll actually bounce here. So I got to make sure that's not happening. So I'm going to be thorough. I'm going to check, you know, a number from this area, the middle here. So I'm going to put 0 in. 9 minus 0 squared is 9. So I get a positive answer. Okay, so this part's good. This part's not good. Then I'm going to try 4. I would get the same thing. So this part's not good. So that means my domain are all the numbers, okay, starting and including -3 all the way up to 3. And that's how you can write that. So remember, brackets mean it includes it. In the next one, I'll show you an example of where we use a parenthesis. So in g of x here, the problem area is going to be when this bottom, my denominator, equals 0. So I can't divide by 0. So I need to figure out when this equals 0. Okay. If I solve here, okay, that's when it equals 0. That means x cannot equal -1/2. So I could say, okay, my domain is all the reals except -1/2. Everything else will work. Or if I want to use my bracket notation, I would say, all right, we can go from -infinity up to -1/2. I can't use -1/2, so I give it a parenthesis. And then everything after -1/2, okay, not including -1/2, all the way up to infinity works. And we never include infinity or negative infinity because they're not numbers. I mean, it's a concept. It's not an actual number. I'll go through a couple more examples here. All right. Is this a function? Okay, so is y a function of x? Well, if I solved, I would get y equals plus or minus the square root of 3 minus x. That plus or minus would mean no, it's not a function. This one is a function because I've got y equals x squared plus 4. There's no plus or minus. That's fine. What is f of 7? That means I'm going to put 7 in the place of x. Okay, so f of 7. Okay, replace the x from here with a 7, so I replace this x with a 7. And now I'll figure that out. 49 plus 4 is 53. So f of 7 equals 53, which means the point 753 is on the graph. If I do the function when x is x minus 3, that means I'm taking out the x, putting in x minus 3. And now remember, we don't distribute our powers across a sum or a difference. So what this really means is I have two of these parentheses being multiplied together. And I'm going to distribute x squared minus 3x minus 3x plus 9 plus 4. Okay, x squared minus 6x plus 13. Okay, that's what f of x minus 3. Okay, here, this is another piecewise, which we'll get to more in depth later. But if I have f of 4, okay, 4 fits in this range. Okay, and it says when x is greater than 0, I use this function. I'm going to plug 4 in there. 4 squared plus 4, which is 20. Here, this fits into this range, so this domain. I'm going to plug it into this function. So I have 3 times negative 3 minus 5, which would be negative 14. Here's your assignment for that one.